So, hello everybody. My name is Steffen Moritz. I'm from the Institute of Data Science, Engineering and Analytics from TH Cologne. And as you probably realized from the name of our institute, with engineering and data science, we're actually doing a lot of things with industry partners and a lot of things with sensor data actually. And with sensor data, you nearly always have problems with missing data. So missing data is a well-known problem, well, at least for us. So usual things in our projects, we work a lot with water industry and with energy industry, is like the sensors won't work, or there are problems with data transmission. Maybe there's a problem with data storage, or we made an error while data processing. And well, usually we try to make things right, but there's always something unexpected which doesn't work somehow, and then you still have missing data. For example, here's from one of our projects. That's a water reservoir, and we wanted to send our data out. And well, we thought easy job. And later on, we just realized, well, the mobile cell reception isn't that good, and only if the weather is very good the data actually gets sent. So we fixed this later on, of course, but for the first half of the year, we had, well, kind of missing data always in our data. So, and well, one of our first insights actually is avoiding the missing data is usually the best solution, of course. But as I told you, there's always something unexpected, and well, this led us to the development of the Imputation package, which we well published on CRAN some time ago. We recently published the 3.0 version of this package, and it's designed for well, replacing NAs in time series actually, so imputation. And well, it has some limitation. It's for univariate, equidistant, and numeric data. And as we realized it, and over the years, there were quite a lot of other people who came to us with questions or had some, well, found something in the package which was interesting. And so we realized, wow, we're not the only ones actually with this missing data problems, and there are quite a lot of other users, like from hydrology, even finance, tropical medicine. We were quite surprised to get this kind of feedback somehow. So, well, I'll explain something about the package and about imputation for time series data. First, let me explain something about imputation of time series data in general. So imputation in general works because there is some correlation in the data. We don't make up the NAs we replace. Of course, there must be some correlation in the data. And for cross-sectional data sets, that's usually intervariable correlation. If you have time series cross-sectional data, you have, of course, correlations intervariable and intertime, which you can employ. And if you're looking at univariate time series, like we do, well, we have just the correlation of this variable in time, and we have to work with this and come up with solutions for the NAs. Another point is, even if you have like time series cross-sectional data, so we have a sensor panel and recording multiple different values, what very often happens is that, of course, if the transmission fails, it fails for all of our sensor values. So in theoretical, we would have correlations between different variables, but due to the missing value pattern, we don't have these correlations. So we still have to rely on univariate imputation for these variables. If you take a look at CRAN, about this imputation packages, you can see there are multiple packages for cross-sectional data like mice, MI, VIM, several. Then you have some for time series cross-sectional data, and then you have packages which you can use for univariate time series imputation. And usually you couldn't use one of these cross-sectional imputation packages for like univariate time series. This just doesn't work. And the other way around, it also doesn't work, of course. And for univariate time series, you have like pre-programmed the MPUTS package, but there are also like some functions in the SU package, and the forecast package. I guess there's also one for like univariate time series imputation, impute PSF. There are also, I guess, one function in this package. And if you want to get a bigger overview about imputation packages, I can recommend the CRAN task view, which is quite new. It was recently put online from Julie Jose, Nicolas Tierney, and Natalie. And also the R-Mistastic webpage, which is a project sponsored by the R Consortium, which is also by these people and Imke Meyer. And it's a great resources to getting an overview about missing data packages actually in R. So, well, how to deal with missing data in time series, or how do we usually deal with this missing data in time series? Like usually you start with like some visualizations, making some missing data statistics to have a feeling like how can I handle this missing data? Because we also have some data sets which we recorded, sensor data sets, where we have like 10 missing values in 1 million observations. And in this case, it's quite easy. We do some very quick fix with some very casual method and don't care about it. If you have more missing data or some certain patterns, we have to treat it differently. So first we would like visualize the stuff, and afterwards we can select our approach, how we go on with this missing data. Do we just keep the missing data, which also sometimes makes sense. Always depends on what we want to do afterwards. Do we have some process which actually needs a complete data set, or do we want to do, for example, modeling? And there are also modeling methods which can handle missing data. Then we also can keep the missing data. Or do we want to perform imputation and replace this missing data? And well, in the next step, we actually try to select an algorithm which fits our data. And well, all of these 3 steps, our IMPUTS package tries to aid, so like give some support for these steps actually. So I'll give you a short introduction to this package. So it was inspired from our own sensor data use cases actually, and these are rather big time series. So what we offer is like a combination of fast and some rather advanced imputation algorithms. Fast because sometimes the more advanced algorithms just take too long. So we wanted to make the package like quick and easy to use and also give quick access to advanced functions. And we'd like to have like the package, so the whole imputation process, like from like visualizing stuff, doing the imputation and doing some retrospect analysis in one package, so that we have one workflow. So we have there like some things for analysis before the NA action. There's 3 different missing data plots to get an insight into the data. Some NA statistics function where we can get a lot of output about different statistical things about the NAs. Then we have these different imputation functions. These are 5 fast imputation functions, 4 more advanced functions, and then you can do some analysis after the imputation to look, well, does this work good? Doesn't it work good? Well, as you see, it's quite easy to use. You have some algorithms, all starting with NA underscore, whatever. You have above the more simple ones, LOCF, whatever. Below you have a little bit more complicated ones, like down seasonally decomposed missing value imputation, and you have Kalman smoothing and state space models, something like this. So this always has the same pattern, NA underscore and your algorithm name. It's quite easy to use. And what's quite nice, we also talked about this today, it can handle all kinds of inputs. It's quite simple structured actually. You give a data frame in, you get a data frame out. It's just if when you give it in, it has NAs. If you get it back, the NAs are replaced. And that works for actually all kind of time series classes. You give a SU object in, you get a SU object back without NAs. So it's quite easy to integrate in your workflow, actually. And yeah, you would use it like this. You have your data. You can use pipe operator. For example, you do a seasonal decomposition here, seasonal decomposed imputation there. And then you do your further steps. You can integrate it in your pipe. Or you can use it more the other way, just like this, and perform it on your data. It's quite fast. We try to, because of the sensor data, we have this thing that we need fast imputation for the simple functions like moving average or last observation carried forward. You see here, like, for example, if you use SU or ImputTS, these LOCF functions are quite fast. If you do your own implementation or something, some other packages also have LOCF implementation, they are, well, a lot of slower, like 10 times or more. So if you have a lot of data, this makes sense to use this. So as I said, we have different algorithms, and usually we have these algorithms here, and these algorithms are the, well, top-level algorithms, and usually each algorithm has some parameters. And for example, if you have NA underscore interpolation, you can choose between spline or linear interpolation. If you have, for example, NA underscore moving average, you can choose between simple moving average, linear weighted moving average, exponentially weighted moving average, and so it's actually a little bit more than just these algorithms. You have some different options you choose from. So yeah, let me quickly guide you through some process here. You would do some visualization, which we offer in this package with thesis, so we can see, oh, this is our NAs are distributed like this. There are that many NAs. Sometimes, for example, for sensor data, you have series which are really, really long, so it wouldn't fit on these plots. Then we have some plots where you get it in bins that you can see, oh, well, the middle bins here will have quite a lot of missing data. We have these stats where we can get a lot of additional information. For example, 2 NAs in a row is the most occurring NA gap, or we have this percentage of NAs, the longest gap size is this and this. So all kind of additional stats about the NA and an NA pattern. Then you would perform the imputation process. Let's just take this time series, for example. Now, well, the red part is actually missing. Then we just use NA underscore mean, and we would get this imputation you see. And that's also an example why you wouldn't, of course, use mean imputation, because it's a quite simple method, and everybody would say, well, you don't use mean. It's still in the package, but you would use an advanced method for this one. Like you can see, it has seasonality and trend. So we'd probably use something like NA underscore C-split, and then you see the imputation works really good. So, well, maybe it's how a process would look like. You can integrate in all kind of, well, workflows. You have your data set, then you run interpolation, NA interpolation from our package, and then you forward to other steps, actually, which you might want to, well, use. Yeah, and some outlook and discussion. So our future plans is actually these plots. We want to transition them to ggplot2, just looks better in our opinion. We also plan to add additional algorithms, some recurrent neural network-based or some more pattern-based stuff. What we are always thinking about is adding some multiple imputation or something accounting for uncertainty. But actually, it's also that the concept of multiple imputation from like the cross-sectional data sets doesn't transfer one-to-one to this univariate time series stuff. And well, what we also plan on adding is like some, well, automatic model selection and evaluation via over-imputation. That would be quite nice because I get a lot of questions of users, should I use this or that algorithm actually? And well, maybe this can give small hints. Well, thus far, so like if you like the package, download it, use it, and if you want to contribute something, here's the GitHub address. We are also open for contributions always, and thanks a lot.
Thank you, Steffen. Do we have questions? I was the first one back.
Can you also simulate missing value patterns?
Sorry, can you repeat it?
Can you simulate missing value patterns?
No, you can't. Oh, sorry, you can't at the moment.
Thanks for the nice talk.
But maybe to the other question, I guess there's some other package for like time series where you can do it. It's called, I think it's called Impute Benchmark or something like this. I guess these have some options for like simulating kind of missing data patterns. So.
Can you say maybe one more word or a sentence when to choose which model, when to choose which algorithm, dependent on the kind of the data, the domain of the data, and how much data is missing at once? So how big are the gaps?
That's really quite an interesting question. And that's actually one thing which makes most effort for me, because a lot of users write me emails and ask, hey, which method should I use actually? So maybe I should add more documentation to this. But it's also kind of course, it's kind of difficult question because it's always very data specific. One thing I can say is, for example, if you have seasonal data or trended data, you would like to use the more complex method with like the seasonal decomposition imputation or seasonal split imputation, or like the Kalman smoothing on ARIMA models, something like this, because otherwise you won't account for the seasonality somehow. And if you have something, for example, which you have very, very large data sets, then probably the more advanced functions will just take forever, and then you have to a little bit go to the, well, more basic functions like moving average or something like this, which still will do a good job, rather. Yeah.
Yeah, thank you for the nice talk. This algorithms is for univariate time series.
It's for univariate data, and it's actually like this. You can input multivariate data sets, and but if you do this, you will get your data sets filled back. But you must keep in mind that you just do univariate on each column separately.
Did you consider, let's say, problems like with 5 or 6 columns, 5 univariate columns, where their data is missing and their data is missing, such that you have to choose some algorithm what to do with the corresponding columns?
No, as you mean some time series cross-sectional data?
Yeah.
No, actually, there are packages for, especially for time series cross-sectional data, and I wanted to keep it specialized to univariate data, actually. Yeah.
Hi, thank you for the talk. How it behave with stochastic data, for example, precipitation or wind measurements?
What was the last wind measurement?
Wind or precipitation data. That is really stochastic, and the imputation usually doesn't work really well.
Yeah. Well, it's maybe something we have to discuss afterwards. I mean, I often get questions and people asking me about the data, and often it's always the case you still have to look at the whole thing somehow and evaluate your results. And I mean, like this whole imputation stuff, it's some way, well, it leads somehow to, well, that's an easy method. I have missing data and just put it on there and my problem is fixed. But usually I get a lot of requests and sometimes I have a really bad feeling about them using the methods because I really know probably this isn't 100% correct. You still have to check a lot of these things and look specifically for your data. Is this the right way to do it actually? And you can, of course, also introduce errors and like bias via the things. And so it's, well, a little bit decisive, this missing data stuff.